All right, what can we do? So I modified my numbers just a little bit here. And now they provide me with a sketch, but I usually like to make my own. That just helps my brain settle in on the problem and process it, trying to connect things I've seen before. All right, so A and B are 130 kilometers apart. We have a signal from B arrives tenths, hundredths, thousand, 2 10,000ths of a second before the signal from A. So B gets there first. So B is obviously closer. All right, so I just I'm gonna draw on this for a second before I make my own. So a signal heads out, gets to the ship. Signal here comes out, gets to the ship. Okay, so B gets there sooner. And what else do we have? Hyperbola, yes, I got that. Coordinate system with the origin is exactly in between there. All right, so I'm going to start sketching, and my first sketch is not going to be to scale. I'm just kind of messing around. So I have some origin here, so let's put that there. And then these two are 130 kilometers apart. So let's say we go 1, 2, 3, 4, 5, 6.5 that way. 1, 2, 3, 4, 5. Oops, I lost track. 1, 2, 3, 4, 5, 6.5 this way. So A is going to be around right here, and B is going to be around right here. And again, I'm making sure this is, if I scale every one of these as 10 kilometers, then that's 130 kilometers right there. Okay, and then again, this is my origin. And the ship is coming toward the two of them on a hyperbola. And so then somewhere in between here, let's use blue maybe, if that wasn't land, the ship would pass in between here. And otherwise, it's heading on like an asymptotic path. Remember, hyperbolas have those asymptotes. So I'm going to draw in an asymptote here in red. So let's just say, let's make that the asymptote there. And so the ship is heading on a path that starts off closer to the asymptote. Let's maybe start over here and is heading toward this point here. And then it would turn, and there's a symmetric asymptote on the other side, and it would head away. So here's my ship. I'm just going to put a point, call it ship. And then the A and the B, those have to be the focus points. So this right here has to be a focus. This unknown point right here would have to be a vertex of the ellipse. So then if I say this is the x-axis coming through this way here, then this equation is going to have to be something like x squared over a squared minus y squared over b squared equals 1 if I want the focus and the vertex to be on the x-axis. The x squared is going to go first. Okay, what else do I know about an ellipse that might help here? I know the difference in time here of the signal from A and B to the ship, and I know how fast the signal travels. So I have this rate, kilometers per second, and I have this time, and I know distance equals rate times time. That's going to come in because ultimately I need distances here. And that time, again, it's the difference. And so that would be time A minus time B. And the other important thing about an ellipse, hopefully you remember reading this in the book, is unlike a, sorry, not an ellipse, a hyperbola, an ellipse, the sum of the distances to the focus are always the same. With an ellipse, it's the absolute value of the difference of the distances is always constant. So for a hyperbola, the absolute value of the difference in distances to the focal points, the foci, is always constant, and that constant happens to be 2a. So we can calculate that constant based on this rate and time they give us. So they gave us a difference in time, so our t is 0.0002 times our rate. And do these match up? Seconds there and seconds there. Yep, is 300, 1, 2, 3. And that kilometers per second times seconds is kilometers. All right, what does that give us? Calculator, please. Let's reset this Desmos. So 300, 1, 2, 3, that's our speed. So rate times time, 0.0002 gives me 60 for our constant. So that's equal to 60, and the 60 has to be 2 times A. And so that tells me that A is 60 over 2, which is 30, and A is the value of the vertex here. So I didn't quite draw that in the right place, 10, 20, 30, it's more like right there. So now I know the vertex on this side is the point 30, 0. And then I guess I don't worry about the other one too much. All right, so we're getting partway there. We have our A down here. Next, we need to find our B. And since we know the focal point, we can find our B. So that's not too bad. All right, so let me see. Can I fit that on this page? Not really. So we know for this hyperbola that the distance between those two focal points was 130. So from the origin, the distance to one of them, that's our value for C, is 65 kilometers. We just calculated that A is equal to 30 kilometers, and the values of A, B, and C, and again, C comes from the focus, and then the A is from the major axis, and B is from the minor axis. We know that A squared plus B squared equals C squared, just like the Pythagorean theorem. So we've got 30 squared plus the unknown B squared has to equal 65 squared. So B squared is 65 squared minus 30 squared. And then we just take the square root of each of those and we get B. And so that's square root. All right, let's calculate. So we have B is the square root of our 65 squared minus 30 squared, which is around 58-ish. And we know that A is 30. And so then the equation of this ellipse, let's graph it just for fun, should be x squared over 30 squared minus y squared over that number, I'm just going to call it B because I labeled it B, has to equal 1. And then we're going to have to zoom out because we need to see out to like 65 on each side. So zoom in, zoom out. All right, so that's that right there. And there should be a focal point for this, for example, on the right at 65, 0 would be one of the focal points. And again, I said my picture wasn't to scale, their picture probably wasn't to scale either, but that should be our scenario right there. And again, I picked different numbers than mine right here. What did we want to answer here? Find the equation. So then if again, I had the 130 there and the 2 10,000ths of a second there, then my equation would be something like x squared, and I would have to do a rounded version of b to type that in. 30 squared is fine there. Oops, as long as I put the square in there. Plus, no, minus hyperbola, not an ellipse. Y squared over, and when in doubt, I usually go to like 5 decimal places on this homework system. So 57.66281. And then don't forget to square that sucker. And then that should equal 1. And again, it looks like the red sits on top. It's not exactly the same, but it's close. I have a slightly different set of decimal values on my second version there.